another idea. So what I'm going to discuss now, as we have already discussed that in the graph cycle exists. First we are going to check today. Means we have already discussed that how we can know that whether a cycle exists. If we traverse something, if we get the same node, we'll get to know that there is a cycle. Okay, let's say it can be BFS or TFS traversal. It can be anything. You can just make a map of visited node. If you're getting that node again, if you're checking whether this node is being visited or not, if it is saying that it is being visited, it means there is a cycle. Their cycle exists. Okay. So now what the let's say what I'm going to discuss about the cycles. Let's say okay. Well, okay. Now it is working. Okay. Let's say this is a graph something like this 0. Let's say 1 is here. Let's say 1, 2 is here. Let's say okay. Let's say some other nodes are there also. 4 and 5. Okay, it will be 3. Let's say 3 and 4 are there. By seeing this, we can know yes, there is a cycle in this graph. Okay. So if I want to know if there is a cycle in my graph, I want to know means what are the nodes that are that are there in that cycle. So what I want as an output is 0, 1, and 2 because these are the nodes that are there in that cycle. Let's say if I've added one more S here, in that case there is a cycle here also, there is a cycle here also. So what I want the output, I want the output as all the nodes. It should print all the nodes because all the nodes are there in the cycle. Okay. So I just want to print that what are the nodes that are there in the cycle. Okay, 0, 1, 2, 3, and 4. As the question is clear, means I just want to print what are the nodes, what are the vertex, which one are there in that cycle. Okay, that are making the cycle. Okay, so what I'm going to do, I'm going to solve this question with the help of degrees. What a degree of in the graph is, it means a degree is for the every node. Let's say here degree is 2 because there are two direct path from this vertex. The degree is 3 here. The degree is 3 here, 2 here, and 2 here. I think degree of is loop and cycle is the same thing. Yes, loop and cycle is the same thing. Show here in the graph. Okay. So if there is a cycle in this graph. So there is, let's say, okay, I was talking about the degree. So 3, 2, 3, 2, 2 are the degrees of these vertex. Let's say I'm going to if I'm going to remove this node, or let's say I've removed that node, so we'll be updating the degrees of each and every. Okay, okay, just okay. The degree of this is now 2, and degree of this. Okay, just now degree of this node is 2, and degree of this node is we have already. Means we are going to update it as 1 because this is having a direct path from this node to 4 only. Okay. So how I'm going to solve it? The algorithm, what I'm going to use for this is, let's say what the algorithm says. First check what are the nodes that is having the degree as 1. 1 degree means we can say that in our, if I'm using the map representation of our graph, I can use the map representation here as well. How we can know the degree? We can know the degree. Let's say if I'm checking the degree for this, how I can know? I can just check what is the size of this. What is the size that is there in the map at this key? Okay, at this key there will be a map there will be a vector and the vector, and in that vector the 4 will be stored, because from 3 we can directly go to 4 only. So how I can know the degree about any node? I can just check what is the size of that vector that is there at this key value. Okay. So if I'm talking about my map representation, because with the help of map in the graph, we can do anything. I think. We can solve any number of questions, any type of questions. Okay. So here I'm going to use map as well, or you can use the adjacency list or adjacency matrix. You can use anything. So it is so in this case, the this is the degree of this node. So what the algorithm says, first create a queue. Let's say I'm creating a queue here. The queue is doing like something this, and add all the nodes of degree one in that queue. So I'm adding my all the nodes of degree one. Let's say this is 3. Only one node is there that is having the degree one. So now what I'm saying, uh, I've means push that value into that queue. I'm saying that run a while loop until my queue is not empty. So I'm running a while loop until my queue is not empty. Okay. Let's say this is a while loop until my queue is not empty. So what I'm going to do, I'm going to just remove this. Okay. Because if this is having a degree one, it cannot create any cycle. For creating a cycle, it should at least have the degree as 2, at least degree 2. Okay. Degree 1 cannot, if let's say it is creating a cycle, then by default its degree will be 2. Okay. So I'm saying remove this path, and let's say I'm going to remove this node from my map. So let's say I've deleted that node from my map. So 3 is being deleted. Before deleting 3, mark all the nodes that is directly being connected. Decrease its size, means its size should be decreased. Means its size, although or update it, or let's say we can update it, or we can do that its degree should be 2 minus 1 now, because if I am deleting something, if it is directly being connected to this, let's say if it is being connected to this node, if I'm deleting this node, its degree will be minus 1. That all the nodes that are directly being connected with this node will decrease its degree by 1. Okay. So what I'm going to do, if I'm deleting this node, I'm going to delete its degree as minus 1. Let's say I'm going to decrease its degree. Now, right now its degree is now 1. And if I've deleted, if I've now I'm going to delete this node from my queue, and I'm going to check my graph again. If there exists any means any function, if there exists any node that is having degree 1 now. In this case, now it is having again degree 1. So what I'm going to do, I'm going to add this into my queue. That is 4. Okay. So now again this while loop is not empty, this queue is not empty. So again I'm going to delete this 4. And if I'm deleting this 4, I'm going to decrease its degree as from 3 to 2. Okay. Now in my map there is no node that is having degree 1. So we are going to delete this, and we are not having any node that is having degree 1. So now what I'm going to do, I'm going to print all the nodes that are not being visited yet. Means that it means that they are creating a cycle. Okay. Is the question is clear? Means let's say I've created a visited map, and I'm marking 3 and 4. Means let's say if I'm adding something to my queue, I'm marking him that you have been visited, and 0, 1, 2 is not being visited yet. So I'm saying, because we have broken our while loop, because our queue is empty. So now I'm going to check, means what are the nodes that are not being visited is involved in the making of that cycle. Okay. Is the concept is clear with everyone? Do we start from, okay, starting what you are asking? Shadiu, could you complete your question? Do we start from where? What you are asking? Uh, for rest everyone, is it clear or not? One node, one node connected node. Yes, one node connected node means that what are the nodes that is having degree one? First push all those nodes that is uh, in that queue. Let's say there is one more node was there. Let's say five. Let's say five was here. So this is also having a degree as one now. So what I'm going to do in this case, I'm going to push 3 and 5 both as 3 and 5 as in my queue, and after that I'm going to run a while loop. In that case, its degree will be 3 here. So if I'm deleting this node, its degree will be 2 again. Okay, and here the operation will be in this manner only. Okay, so what I'm going to do in map representation, if I'm talking about, although you can use the structure or any other thing for because their data does not matter here. Here the only degree matter here. Okay, please explain the code for closed loop type graph. Shape what you are asking. This code for closed loop type graph. It means you are saying that if there is two cycle exist. Let's say you're asking about this. I think so. Let's say so. You're asking if there exists. Let's say four here. Okay, there's three here and four here. Okay, you are saying that initially there is no degree as one here. So that is the most simple question. What I'm saying that create a queue and add all those nodes that is having degree one. In that case, it is not having degree one. It is not having this three and four. That is not having degree one. So there will be the queue will be already empty. So after that, if I'm going to say while my queue is not empty, while my queue is empty means queue is not empty. Yes, queue is not empty. So our queue is already empty. So we are not going to get in that. And our visited node will be let's say visited map will be empty because we have not visited anything. So if I'm going to print all those value that is not being visited, because all these value will not being visited, so what I'm going to do, I'm going to print all these nodes in that case, because the code we are going to write in the while loop will not be run in this case. Okay, Shrey, is it clear now? Because first we are going to insert that value by running a for or while loop in that queue, that all the nodes that are having degree as one. Okay, so what I was talking about, if I'm using a map representation, because let's say 0 1 2 1 3 4 and 2 is here, I'm not concerned about this whether 0 is connected with 1 or 2. I'm not concerned about that. I'm just concerned about that what is the degree of 2, what is the degree of 0. Okay, uh, because if we have discussed the algorithm, we have not used anything that 1 is connected with 3 or 3 is connected with 4. We have not discussed about that. We were just checking with what is the degree of that node. So if I've deleted 3 here, if I want to decrease the force, no, the force, let's say force degree. So in that case, I can just remove any of the item. Let's say I can just remove any of the item from that vector uh, that is present at the fourth position in that map. Okay, I can delete two, I can delete three, but because we are not, if I delete two as well, so in that case we are not decreasing its degree. We are just saying that it means in that case the three will be deleted, not because the two's degree will already be, in that case two's degree will be three, because we're not going to decrease its degree. Okay, so if I want to decrease the fourth degree, how, what we can do, I can just remove any of the item that is there in this vector that is present at the fourth position in our map. Okay, is the question is clear with everyone? again, let's say if I talk, let's say let's create another code for this. Here our class graph. Let's create the public function void add a dot push back back b dot push back a. Okay. So now what I'm going to do, we have created our add edge function. Let's quickly add this graph first, then we'll discuss about b dot add edge. Let's say first we are talking about this graph, then we'll add this node and check the output, something like this. Okay, b dot add edge from 0 to 1, b dot add edge from 1 to 2, b dot add edge from 2 to 0, 1 to 3, and 3 to 4. 1 to 3 dot add 3 to 4. Okay. Now what I'm going to do, I'm going to say that G print cycle, and it is going to print the cycle. Like what are the nodes that are involved in the cycle? Void print cycle. What I'm going to do now, first I'm going to create an unordered map that is our visited node that will, the first will be the type of int and the second will bool, and name it, let's name it visited. Okay. And now what I'm saying that put all, let's say I'm going to create a queue again, queue of type int, say name is queue, and I'm saying that put all the values that is having the size, that is having the degree as 1. Put all the values in that queue. So how I'm going to see that what are the nodes that is having value that is having degree as 1? Let's say x auto x and map. In the x, I'll be getting x dot first and x dot second. In x dot first, will get the key. In x dot second, we'll get the vector. And I'm going to check for that x dot second. If x dot second dot size, if size of that vector is equal to 1, it means that the x dot first is having degree 1. It means if the vector that is present at this key, let's say in that 3 will be stored, it means if the size of that vector is 1, it means the 4 is having degree 1. So I'm going to add that value into my queue, that is x dot first. Is it clear how I'm adding my nodes that is having degree 1? Is it clear with everyone, or do anybody is having any doubt? How I'm adding that nodes that is having the degree 1? Okay. So now what I was saying, run a while loop, and while my Q is not empty. Okay. While my Q is not empty, what you need to do, int d is equal to Q dot front, and all those nodes that are directly connected with this, because we are going to delete this, all those nodes that are directly connected with this, please remove its degree as, please decrease its degree as by -1. Okay, so how I'm going to do, if I run a while for loop and auto of, if I write auto of x of map of d, then what I'm going to get, that, let's say if I'm talking about 4, I'm going to get 3 in that, in the C. Let's say it's x. In that x, I'm going to get 3. If my d is 1, what I'm going to get in that, I'm going to get in x first 0, 2, and 3. It means I'm going to get all those values of that vector that is present at this position. If I'm talking about this position, I'm going to get the values one by one in my x that is present in this, that values that are being present in this vector that is present, that is stored at position 4 in my map. So we are going to get the x one by one that is there in my map. So if I got, let's say if I'm going to get 3 in that, so how I can remove its, how I can decrease its degree, I can just write x, map of x, and map of x dot pushback. If I write map of x means, it means that it will return a vector, and that vector 1 will be stored 1. Okay, in that case 1 will be stored. In map of in that vector 1 and 4 will be stored because we have not deleted the 4. Okay, so how we can do that? Map of x dot pushback. If I'm saying pushback, it means from that vector I'm just removing one element. It means its size will be decreased. Okay, as well as in this loop I can check whether if its size is equal to 1, now we can say that add it to my queue. Is it clear? Because if there is a node, let's say in that case the 4 was the only node that was having degree 1, and 3 was not having the degree 1, 1, 2, and 0 was not having degree 1. If I have removed something, okay, sorry, pop that. Okay, thank you, man. So if I've decreased someone's degree, let's say this nodes, I'm going to check whether are you now as degree 1. So if map of that map of x dot size equals to 1. If it is equals to 1, it means that your degree is 1 now. If your degree is 1, what you need to do, you just get into this q dot push x. Okay, we have created or visited node as well. If I'm adding something to my queue, please mark visited as true. It means if I'm adding something to my node, it means its degree is 1, and mark this as true. Let's say visited of x dot first equals to true. Okay, and here visited of x is equal to true, because here the x is the node, not the x dot first. Instead of x is equal to true. Okay, and now if you have completed this for loop, how can we be sure that 4 will be popped, not 1? Shrey, as I have discussed that we are not worrying about the data. Either 1 will be popped, either 4 will be popped. The degree of 3 will be decreased by 1. So because now we are doing the adjacency list in ones, that if let's say 1 is being deleted from 3, so 3's degree will be removed, decreased by 1, and at this moment also 1 is pointing to 3. Let's say 3 is not pointing to 1, but 1 is pointing to 3 now. It means there is a connection between 1 to 3. if I ever get to 1, because once degree is 2 will never get to 1. If I ever reach to 1, if I want to check whether what are the nodes that are directly being connected, it will have the data as 3. So we don't need to worry about that, whether what is the data that is being deleted. Because if I talk about because we are just worried about here the degrees. Let's say uh, if I'm not having these data, let's say I'm having just nodes. One side the nodes, the name of that nodes, and then on the second side I'm just having the degree. In that case, what I can do, I can just remove its degree by 1. Or if you want, you can do that. You can create another map in that, and the key should be all these nodes, and the value should be its degrees. Okay, we can use the separate degrees array. So yes, you can use separate degrees as well. So for avoiding that thing, means avoiding that extra space things, I'm doing it in this map only. Okay, you can use another function if you want. If you're getting confused, you can use another set of array or another map. You can use any type of data structure to that. Okay. So here I'm just saving some memories. So if you want, you can do that. Okay. So if I have means checked, if I have removed all these values, let's say now what I can do, if I want to remove 4 from here, let's say if I want to because I've decreased 3's degree as -1. Now I just want to do what I want to do, map of that D. It should also be pop back, because in the fourth the vector in the fourth vector, let's say in the map, if I enter 4 as key, there will be a vector. In that vector the 3 will be stored. So in that case, although it's degrees as well, if we do not remove it, it will not make any difference. But if we are doing that, if we are because in the algorithm says that remove this 4. For removing this 4, if I'm saying that from 4 there exists no path, so I'm doing map of D dot pop back. Okay, we have completed this while loop. Now I'm saying for so I'm saying see out printing the nodes that are involved in the cycle. Okay, printing the nodes that are involved in the cycle. So how I can print that nodes? So I'm going to just run a for loop. Let's say auto x of map. I'm going to check. I have to just print the nodes. So I'm going to just print the x dot first, and before printing that, I'm going to check whether x dot first, okay, is being visited or not. If it is being visited, I'm not going to print it. If it is not visited, I'm going to use a not here. If it is not visited, x dot first, what you need to do is just print that x dot first. Print and space after that. Okay. Let's see whether we are getting the correct output or not. I should be getting 012 or 021 something. Okay, it is saying map of x dot size. Okay, we have not used parenthesis here. Okay, we have to pop from. Okay, yes, man, thank you for reminding me, because we have not popped that value from our queue. That queue will never get empty. So queue dot pop. Thank you, man, for that. That's why we are getting a segmentation code, because we are getting an infinite loop. Okay, it is saying the printing the nodes that are involved in the cycle, that is 201. Let's say I'm creating a node here from 2 to 4, and I'm creating an edge here from 2 to 4. So I'm going to add that into my input from 2 to 4. I should be getting all the nodes. output I should get 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, or 4, 3, 2, 0, 1. Means these are the nodes that are being involved into this cycles. Okay. Is the question, is the code is clear with everyone, or do I need to repeat it again? You can see the code from here. I'm just adding all the nodes that is having degree 1. After that, I'm just running a while loop. If it's degrees, if until my queue is not empty, and what I'm going to do, if I'm popping something from my queue, let's say what it means I have to delete this because it's having degree 1, it is not creating any cycle. So if I'm deleting some node, I'm what I'm doing, I'm just decreasing all the adjacent vertex degree by -1. For doing that, for decreasing that value of that degree, what I'm doing, I'm just popping an element from its vector. Okay, is it clear now? And I'm just marking if I'm adding something to my queue, I'm saying that it is being visited. Please mark it as true. And what I'm doing after that, I'm just printing all the nodes of my graph, and I'm just checking whether it is being visited it or not. If it is not being visited, just print this. If it is being visited, just do not print it. Okay. Is the question is clear, Divyaj? Or if anybody is having confusion whether if I'm popping something from, let's say, from vector 3, either it will pop from pop 1 or pop 4. It does not matter. If you want to do that, you can use a separate map or separate structure, or you can use a separate array for that. Okay. So in that case, you can just store the node and store the degree of that node. Okay. Because here we are not concerned about the data, we are just concerned about the nodes. Is the question is the